Hi friends, welcome to App Insights tutorials. Today we are going to discuss JDK 8 features overview. We will discuss in detail concepts and further. Today we are going to discuss JDK 8 features overview. And when coming to JDK 8 features, there are a lot of changes introduced, and among them some are major changes like lambda expressions, function interfaces, and there are other changes as well. So overall the changes are lambda expressions, functional interfaces, and introduced and improved APIs such as stream API, datetime API, collection API improvements, concurrency API improvements. So if you look at the lambda expressions, like they are like concise functional code using arrow symbol, and functional interfaces are single method interfaces, so which accepts only one single abstract method, and that is called it is used to efficient data manipulation. For the two earlier collection objects, iterator and enumerator, there is a stream comes into the picture with JDK 8, and it is for efficient data manipulation. And there are some datetime API changes are there, so they are robust datetime handling and changes. And next comes collection API improvements. So two earlier collections, and there are some enhanced methods for collections like remove if, replace all. These kind of functions are introduced in JDK 8. Concurrency API improvements is the next one in the list, so which is new classes for parallel processing, and for example completable feature. And the other change is optional class, which handle null values safely. As we know, like it is used to handle the null pointer exception safely. And the next one is for each method in iterable interface, which executes an action for each element in a collection. And default methods, the interfaces evolve without breaking compatibility. And static methods allows adding methods with default implementations too. So in JDK 8, default methods and static methods, and then the last one is method reference. So method reference is used to refer to methods easily, with method itself can be passed as a reference. So that is what method reference is. So if you look at the evolution of Java, Java 1 version to 8 version, so these are the changes. Java 1 having thread features, and then Java 5 introduced concurrent and generics, and Java 6 some phases, and Java 7 some fork join framework was introduced. And coming to Java 8, it's also known as Project Lambda. So in Java 8, these are the features we had mentioned above. So this is how Java evaluated. So next there is a concept called functional programming. So functional programming deals with code in the same way as data. So that means the function is treated as a first class value, and that can be assigned variables and passed to functions. So that means like the data is treated, the functions are also treated in functional programming. They are treated as first class value. That means in functional programming, functions are preferred more, as well as variables. So that is what functional programming. And programs written in terms of functions always return same output for a given input, um, regardless of any other state present in that running program, and that do not cause any other effects or changes in program state. So functions obey this are called pure functions, and they behave in same way that mathematical functions do. So like mathematical functions in functional programming, so programs are written in terms of functions, so there is more focus towards functions. So that is what it is called functional programming. And the functions written in functional programming also they return same output for a given input, okay, regardless of any other state present in the running program, and that doesn't affect any change in the program state. So they are called pure functions. So pure functions also doesn't depend on external state and can easily be combined together. So that is called strong functional heritage. So that is also that is the way that functional programming work. So for example, functional programming we have different examples: closure function and Scala. So in Scala, like here square function is denoted as a value, and some in the brackets x as int, and it becomes into x into x. So that is a square function is assigned x square value. So this kind of syntax is very close to Java. So this is an example of functional programming. So when we mentioned functions are first class citizens, so if you look at the difference between OOPS and functional programming way of writing the code or creating applications. So in OOP we pass objects to methods and create objects within methods using new operator, and so objects are passed to methods and return objects from within methods. So in a function we create in a method we create objects and do return within methods, and we pass objects to methods. This is all about traditional object oriented programming. So when coming to functional programming, we pass functions to functions. So this is a new way of so with regard to Java, this is till JDK up to JDK 8 there was no this kind of feature, but JDK 8 is followed by a functional programming way of creating the programs. So we pass functions to functions like kind of method reference, and create functions within functions, and return functions from functions. So if you look at the difference, creating objects within methods in OOP, and here coming to functional programming, create functions within functions, and in OOP we return objects from within methods, and in functional programming we return functions from functions. So this is the difference between OOP and FP. So when we look at the Java in terms of from the viewpoint of functional programming, so how it is been followed. So if you take the classes or the heart of the Java program, and it's a basic unit of functionality, and the Java platform will load, link, and all code that is intended for execution, so must live inside a class. So here the class is the heart of the Java platform and is the basic unit of functionality, and everything is packaged in that class, and that is load, link, and all code that is intended for execution, so must live inside that class. Interfaces can't be instantiated directly, and instead a class must be defined that implements the API defined by that interface. And so arrays hold either primitive or instances of classes or other arrays of same type, and the primitive types are all defined by the platform. So this is how it happens. So this is how the functional is Java. And if we go further, strongly typed programming language, and types are either reference types or primitive types. Reference types are classes, interfaces, and arrays, and every type must have this one name that is referred by, and even the anonymous classes, inner classes, still have some type, so by which the programmer must refer to them. So the type of the interface that they implement, even the anonymous inner classes are referenced by some type. So this way, like all the coding programming units are all referred by some type. So that is a strongly typed programming language. And if you look at runnable or new runnable, public void run, so here system out is given hello world. So here if you look at the runnable is interface, and so void is the method that is implemented by the class, and that system out is written over there. So this way every value in Java is either in primitive or an instance of some class. So this is how, if you look at Java 5 types, like we have enumerator types, enums, and annotations and generics. These are the major changes introduced in Java 5. So if you see, enumerator types are like they are similar to classes in some respects, but they have the property that only a specified number of instances may exist, and each instance is specified in the class description and distinct. So the enum construction also permits additional patterns that are sometimes extremely useful, and these are the enums. And if we look at annotations, so at the rate symbol we use, and we mention some annotation to some interface, to some interface, and by using the keyword, so at the rate. If you use at the rate, and that is indicated as annotation type. An annotation is annotation is used to annotate elements of code with additional information that doesn't affect the behavior. So the annotation does not affect the behavior, and it is used at that symbol and the annotation name for that interface. And next comes Java generics. Java generics are before Java 5 there was no generics, so there was no parameterized types, but Java 5 onwards, like generics were introduced, and so we started mentioning the type of the collection for the one which was created while writing the code. So for example, a list is created with a list of string, list of integer, list of double. So we mention some generic string, integer, double. So that is what the generic. While creating a list, we mention the type. So that way we are in advance we are providing the type of the list that it is going to be created. So we are letting the compiler know the type of the list object, and that is what generics is called. And next coming after JDK 5 is a major upgrade to Java is Java 8. In this we have this lambda expression, and simply like empty parenthesis, an arrow symbol, and the block of code as like system of println we are giving here. So here it is not taking any parameters and not returning anything, so it is still perfectly statically typed and anonymous. So this is a way random. So here we have some parentheses on left side to arrow symbol and some block of code on right side of the arrow symbol. So this way lambda expression has some two parts, like on left side and right side. So left side denotes the and in JVM. So this is very strictly tied to the concept of classes. So class loading is central to the Java platform's security and verification modes. So it would be very difficult to conceive a type that was not in some way represented through a class. So coming to lambda expressions, so we have SAM is single abstract method in the functional interface. So here some lambda expressions are given as example. Sum of xy is denoted by arrow symbol, and x plus y, and so without some function also we are just xy parameters we are passing, and x plus y we are calculating, and this is another lambda expression example. And if you look at the thread class also with lambda expression and without lambda expression. So without lambda expression is the new thread we are passing new runnable, and we are overriding our run method and starting it. But in with lambda expression, like we are creating a new thread object, and so here we are we are writing some lines of code for run method. Here the run method is function interface. So here we are not without the run method is mentioned, we are writing the code defining the run method instead of lambda expression. So this is how lambda expression work without using the function name. And if you look at more examples, so lambda expression is an anonymous function, so which are like methods but not associated with a class. So this is what lambda expression. So here the syntax for this is, so parameters on the left side of the arrow symbol and lambda body on right side. Here this arrow symbol is known as lambda operator, and this is how lambda expression is written. And if you look at the rules of lambdas, so rule 1 is single parameter, do not need brackets. We can directly mention without bracket we can directly mention the parameter name. And next rule is no parameters must have empty brackets. So if you are going to have some then we mention in the brackets. And next rule is single line lambdas do not need braces or explicit return statement, and single line lambdas do not need braces or explicit return statement. And the last rule is body of the lambda may throw exceptions, and these are the rules for creating lambda expression. More examples of lambda expression are we already seen. So this empty parenthesis is arrow symbol and system out, and here x becomes x plus 10, and int x into y becomes return x plus y. String x string y becomes x dot length minus y dot length. So this arrow symbol also we can call becomes, and x becomes, if x mod 2 is equal to 0, then return even, else return odd. So like this we can create lambda expressions. So why lambda expression and where to use lambda expression? So a lambda expression is used only with a functional interface. So if there is no function interface, there is no lambda expression. So that is the first and foremost rule, and so that is that kind of interface is called single abstract method type SAM. So this way lambda expression is providing the implementation of that single abstract. So first we need a function interface for a lambda expression. It's also called SAM, that function, that interface with a single abstract method, and that method's implementation we are providing in lambda expression. So that is where lambda expression is used. So lambda expression is used wherever the type is function interface. So this is some real-time example, like Mr. Ted says I take the business requirements and give it to programmers for execution. So here interface is having some requirement, and lambda expression is doing that execution. So this is how we can correlate this example to lambda expression. So this way, what is happening from JDK 8 onwards, there is happening some paradigm shift, and the paradigm shift from what to what, that is imperative to functional. So paradigm shift is happening in JDK 8 from imperative to functional. So if you look at the JDK, our imperative paradigm code, and in JDK 5, and in JDK 5 also there is little bit change of paradigm, and the paradigm shift is happened from JDK 5. If you look at the code, like in the above lines of code highlighted in red, here we are creating some list object of integers type, and in order to print it, we are using traditional for loop, and we are using system out println, and this is how we are looking through the list of objects and printing them. And when coming to JDK 5, so there is extended for loop is used here. So for loop within the brackets, simply some parameter is used, and with colon symbol. After that we have numbers. It's a list of the list of integers, and it's simply giving system out println. So it will automatically print. It will the extend for loop will look through the list of the integers objects, and it will print in the line. So this is how some slow paradigm shift happened from imperative to functional in JDK 5. So when we say imperative, so there is some code smells. So what kind of code smells is what kind of code smells exist in imperative type and in functional programming type. Imperative types, we mainly focus on how, so that means like more focus is on how rather than what. So like we spend a lot of time in doing things, in how to do things, and moving the parts. And here imperative is how and mutability is moving parts. So this is more focus in imperative style of programming, imperative style of paradigm. So if you look at the above example of code snippet, so here int I is declared and initialized with 0, and every time this the loop I is verified with the size of the list and incremented by 1. Here we are focusing more on moving parts. So here with this kind of way of writing the code, we tend to introduce more errors and bugs in the code. So as there is a lot of volume of mutation involved here. So this way, in imperative style, we are focusing on how and focusing on focusing on moving the parts. So we are moving the parts more and more. Moving is happened here. So if we move the things more and more, so there is a chance, or there are possibilities of more errors and more bugs in the code. So with a more volume of mutation, and with this kind of programming, it is also hard to make concurrent also. It is very difficult to make concurrency, difficult to achieve the concurrency. So what we are doing to resolve this, to address this issue, so we are refactoring this kind of code into declarative style, where the focus is not on how but on what and on immutability. So what we are doing here, so to address this kind of issue, in order to avoid more bugs and errors with the style of imperative coding, imperative coding style, we are refactoring the code that is created in the imperative style to declarative style. To what? To declarative style. To declarative style, where the focus is not on how but on what and on immutability. The declarative style programming focuses on what and on immutability. So here, if we try to understand this, so what means like to satisfy the requirement, just to satisfy the requirements and just to get what is required, rather than spending a lot of time on how. So here in declarative style, it is mainly focused on what to get and on immutability. Immutability means less moving. So very less, hardly the things are moved. So without moving anything and without focusing much on how, only focusing on what, we are achieving the results, better results with declarative style of programming. So that is what JDK 8 changes, 8 features are introduced, keeping this in view. So if you look at more detail in functional programming, so for example, so if you take same code mentioned above, the same snippet of code mentioned above, if you take one version, it is function interface. Suppose there is one function interface consumer, and it is having some accept method which takes a value. So that is written here like list of integer objects. It's called numbers, and this list is created with arrays of the elements 1 2 3 4 5 6, and so we use for each function for this, and simply by using the lambda expression we are printing the elements of the list object. Here for each method working on collections and takes a specific function interface as an argument here, that is consumer, and the function interface defines the contract for number of parameters. For example, if you send more than one parameter, you get compilation error. So here this way it is converted to lambda expression, and the same code snippet like we can even further reduced and the concised version of the lambda expression. If you write, it will be like numbers dot for each. So that's it. It is even more concised form of the above code snippet. And even if you go with meta reference, so it will be further made simple, like numbers dot for each. System out is object, out is object, system is class, and we can use println as meta reference. So it is further reduced. The code is further reduced and denoted in more concise form. So like this functional programming works. And if you look at under the hood for a lambda, how it works under the hood. So how lambdas are converted to anonymous inner classes at compile time. So this section mentions how the under the hood how the lambda expression conversion happens. For example, step 1, write a sample.java with anonymous inner class, example new consumer, and compile it. Okay, you will see 2 .class files generated. So this is under step 1. We write some sample class and some anonymous inner class inside that, which is consumer. So here 2 .class files are generated, and in step 2 replace the anonymous inner class with a lambda expression and compile it. So you will see single .class file generated. So in above step 2 .class file generated with the traditional way of creating anonymous inner classes. Now inside sample.java we are going to create some consumer inner class, and the compiler generates 2 .class files, and in step 2 we are replacing the consumer inner anonymous class with a lambda expression, and only 1 .class file is generated. So here if you repeat the step 1 with multiple copy paste snippet of anonymous inner class, so we will see multiple .class files generated. So similar way we created a consumer inner class. If we create multiple classes, so multiple .class files are generated. And repeat step 2 with multiple copy paste snippet of lambda expression, you will see only single .class file generated. So here as many as inner classes are created, then that many class files are generated without using lambda expression. And if you use lambda expression, only one dot class file is generated by compiler. So this is how under the hood lambda expression is created or converted. So here it's something cool inside happening like this. So next comes the feature invoke plus dynamic. And if you use any Java PE command with hello lambda class, so it will disassemble this class file into this readable format. And Indy is introduced in Java 7 as a feature implemented for dynamically typed languages of, for example, Scala and JRuby. So in JDK 8, lambda expressions are introduced to replace anonymous inner classes. And as with anonymous inner classes, with lambda expressions there is no creating, delete and garbage collection of anonymous objects. So this way we are reducing runtime memory footprint. We are reducing runtime. So how Indy works? So attach and Indy attached to a function you want to invoke dynamically and reattach at runtime. Call set function. Function pointers are available at the JVM level to program. How is it implemented? When you create a lambda expression, the call to lambda expression will simply become invoke dynamic, and the lambda expression itself will be one of the three based on the context. So one is a static method, and second is an instance method, and third is a routing for invoke dynamic method to another method in existing class. So the next major change is streams. The most important feature for Java 8 and the real power of Java 8. So what is stream? A stream is used to operate on collection of values, and with the upgrade to earlier iterator, so which was having only one method like as next, and a stream is introduced further to iterator, and with more functions, more methods in the streams. So this way, like a stream is used to operate on collection of values, and interface to process collection of data. It's an interface to process collection of data, and it expresses segregation and reduction, and it facilitates operation pipelining on bulk data. So this is what a stream is all about. So streams include like inside lambda operators like map, filter, sort, projection, etc. So, and in terminal operators, there are collect radius for each min, max, etc. or the methods are available in streams API. So here streams are lazily executed. That means like in some of the methods do not do much work, like map, filter and all, like until the execution reaches terminal operators like collect, reduce methods. So that is why it is called lazily executed at a terminal operator. So if you look at the streams in detail, like So there is map function is there, and it will transform the values, and a map is applicable to function. It will take input element and gives output element. So like a similar mathematical function, so which transforms input to output. So the same way a map function, it will take input and give some output element. Also the number of elements in the input is equals to number of elements in the output, and so for example, so we have real-time example like in a class, number of student names, that means number of students equals to number of people. So that means names, every person has some name, so automatically the number of names will become equals to number of people. And if you take the same people as example, number of names not equal to number of phone numbers, so it is not guaranteed that every person has some phone number associated with them. So that's why the number of names is not equals to number of phone numbers. So that way, like map works as like example map, we are passing some element e, parameter e. So parameter e becomes e into 2 of same type and lambda expression, mapping parameter e becomes e into 2.0. so this is transformation type. So here syntax, if you look at the parameter of stream t is coming as an input, and the map applies a function tr to input stream of type t and returns a stream of type r. So this is how map works. And a real-time example like here list of numbers created, and in imperative paradigm style. So this is how the code created, and in functional, this is how the code is created by using the map to int. So this is how map works. Next we have reduce function. So reduce some streams. So reduce transform the collection into a single value or non-stream itself. So when a reduce is applied on the stream, it will transform the collection into one single value. So that means like a stream is a sequence of objects, and in the reduce method, so this collection of objects is transformed and reduced into some value. So a reduce applies a function which takes two input and give one output, that is a binary function. So in case of binary reduce binary function, so it will take two input and gives one output. The reduce starts from 0, takes carryover and element as another input, and then does the sum of carry over the element. So here carryover is from map. So reduce on stream t takes two parameters in this example. So first parameter is of type t, second parameter is of type binary function RTR to produce a result of type R. So where t is the element and R is the both input and output type, because input at one stage which in turn becomes output. So some kind of specialized reduce functions are sum, collect, to list, to map, to set. So this is all the reduce examples. And then comes the filter function of the streams. So for example, a room of wonderful people stand up if your age is 80. So age greater than 80 and age less than 60. 0 less than number of elements in the output. So these are the filter conditions. Age greater than 80, age greater than 40, and age greater than 60. 0 greater than or equal to number of elements in the output, less than or equal to number of elements in the input. So input is if you have a stream T, then filter takes predicate. So takes predicate as an argument which has test method and returns boolean. So in a filter, predicate state is mentioned, which returns a boolean value. So both map and filter stay within their swim lanes, take an element and performs some kind of operation on it, but not looking for elements on the left and right. Example, if I come and ask you your name, and reduce cut across the swim lanes, takes the first element coming in, performs the operation, push the result out, that results becomes the input. Step forward. So here how the filter works, it will perform some operation where so push the result out, again that result becomes the input, and it steps forward. So filter is like filter it keeps on filtering by pushing the result after performing the elements that are taken, which are coming in, and on that result, again that result is used as input, and again the performance of operation is done. So, and stepping forward like that. And finally we have collect method in the stream. So a collect method of stream is like that will collect all the earlier methods output, as after applying all reduce, filter, map, etc. So at the end this terminal operator is used, so collecting the elements in the output. So here the collect is denotes, it can be denoted as 0 less than or equal to number of elements in the output, less than or equal to number of elements in the input. So here input is if you have a stream T, then filter takes predicate and takes predicate as an argument which has test method and returns boolean. Both map and filter stay within their swim lanes, take an element and performs some kind of operation on it, but not looking for an element on the left and right. Example, if I come and ask you your name, this is example, and reduce cut across the swim lanes, and takes the first element coming in, performs the operation, push the result out, that results becomes the input, step forward like that. So this is how the collector works. So if you look at the efficiency of stream, so in the example, so this is the requirement: double the first even number greater than 3 from the list, and the code is written like this, and result is printed. So here imperative code has low level constructs, hides truth, waiting to hurt you. And streams to the rescue. So how the streams are used to perform the same operation um, that is done in above highlighted code snippet. So here streams is used like this with filter, map, reduce, and all these operations. You can do the same operation in a simple manner, and you can achieve the result. So here streams are, as we earlier mentioned, the streams are lazy evaluated. So until that till at Turner operator. So so this is how lazy evaluation example. So here if you look at like so methods like filter and map are called intermediate functions. They are lazy and don't do much work, whereas find first are called terminal function which trigger the computations. So this is why streams are lazy. So all that operations that are all that methods that are used inside creating stream is not working similar, is not spending a similar effort. So some intermediate functions are not doing much work, so hence streams are called lazy. So if you look at the source and the stream, you look at the source and some intermediate functions are used, and then some terminal function is used, and the result is produced. So here the terminal operator is doing more work. Okay, so we had discussed creating rules of a lambda expression. We also discuss rules of not rules of don'ts with lambda expression. So the first rule is like don't push multiple lines of code in lambda, and so it should be concise, and it should be less number of lines. So we should not use much lines of code in lambda expression, and also some no large lambda expressions, and so we need to avoid noise, and so next rule is duplication is evil. One lambda has some code as other lambda, so we should not have lambda expression, both lambda expressions having similar code. It should not be duplicated and should not look like the same. And logic in lambda results in hard to test, so write the logic in functions. So when we are testing lambda, it is difficult to test the logic of the lambda. So if there is any logic to be tested, we need to write in functions. So next comes the major feature, method reference. So method reference is a simple pass through, and receive an argument, don't alter it, but simply pass through. Most ultimate glue code, parameterize an argument, colon system.out is an object on which the println method is called, hence system.out colon println. So parameterize an argument using static method, for example string colon double colon and value of method. Here the value of is static method, that's why we don't use out parameter here, and we are directly using on string class. And parameter as a target, so string double columns, two string. So this way method reference work. So also there is reactive programming style, so to be mentioned, worth mentioning, like suppose if there is web service which returns you call a web service which returns error in place of data, and you have to handle the exception in one of your threads. So this is reactive programming. So here reactive programming highlights these features, and ability to lazy evaluation, ability to communicate, and a higher level of abstraction, and FP++ and parallel streams. So this is a reactive paradigm. So here parallel streams are introduced in Java 8. So here in parallel streams, like we have fork, Jan framework, abstraction, stream partitioned into substreams, aggregation is applied in parallel to substreams, access parallel streams via collections.parallel streams, bstream.parallel. So these are the methods used in parallel stream. So if you look at the parallel execution example, like enter stream.range 0 to 20, parallel filter x becomes x mod 2 is equal to 0 for each system.println. Here we are printing the even numbers from 0 to 20, and or like double average days is equals to months. Parallel stream map to int m to m days average dot get as double. So here the another example for parallel execution. So average days in a month. So other language changes in JDK are like default methods and optional class, and annotations on types. So these are the other changes in JDK 8. So here we conclude with this, like these key features are like invoke dynamic and laziness stream, and so and the functions are pure, and let's all adopt to functional hygiene and write better quality code, and take it into right direction. So that's all, friends. Thanks for watching.